All right, here we go. Question number 40 from our Calculus 1, homework number 1. In WebAssign, it says in the theory of relativity, the Lorentz contraction formula expresses the length L of an object as a function of its velocity with respect to an observer, where L naught is the length of the object at rest and c is the speed of light. They want us to find the limit of this formula as the velocity approaches the speed of light from the left. So what we can do in our scratch work is we can look at what's going to happen as the velocity right here approaches c. And one of the ways we can evaluate this is we can say, well, what happens if the velocity is c? That's going to give us 1 minus c squared over c squared. Again, the velocity approaching c, we can say, well, what happens when it gets to c? Well, it becomes c squared. And then what is anything divided by itself? Well, that's 1, which gives us the square root of 1 minus 1, which is 0. And the square root of 0 is 0. 0 times anything is 0. And we can see that L, which is the length of the object, approaches 0. So for the second part of this question, it says, why is a left-hand limit necessary? That is because velocities cannot exceed the speed of light. So we can't come in from the right-hand side because that would imply that we would have a velocity bigger than c, and that's just not possible. So we would say that L is not defined for velocities greater than c. And that's going to be this option here. And then we're going to submit our answers and see how we did. And it appears that we were right on both accounts, and so that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me, and thanks for watching.